All right, in this video, we're just going to expand on the things we've already seen with the derivative. So more ways we can look at it. Uh, we've seen that it is instantaneous rate of change. It is the slope of a line tangent to a graph at a point. Also, one thing we may not have seen is PVA. This refers to position velocity acceleration. So if I have a position function, I can take its derivative. That would tell me the velocity. If I take the derivative of the velocity, that would tell me the acceleration. We're going to hit that a lot harder later on, but I'm just putting that out there. We are going to see different ways that the derivative is presented to us. I call these sneaky representations. Always think of how that definition looks. So for example, f prime of x is limit h goes to 0, etc., etc. Sometimes we're going to have a limit we have to evaluate we might not think, but is actually just telling us to find the derivative. For example, let's say I have this limit right here. So it looks like something that we haven't seen before or would be kind of complicated to evaluate algebraically, but it looks a whole lot like our limit definition. So they look very similar. Taking a close look, we might see that the h is basically in the same spot everywhere. So this kind of tells us that our f of x should be that 5x squared, because this is f of x plus h all squared minus f of x all over h. So kind of seems like our function should just be 5x squared. So if that's true, that would tell us our derivative using the power rule, which is a whole lot faster, is 10x. So this original question really just has the answer 10x. So another question people often have is, when do I plug things into the derivative? So for example, if I'm looking at the slope of a tangent line to this graph at the point x equals 27, you might notice if you were to plug in 27 first, you're going to get the cube root of 27 and square, you get a 9. So then when you take the derivative, you'll get a 0. But this always happens. If you first plug in the x value, you're always going to end up with a constant. And then when you take the derivative, you'll get a 0. So this really is not the correct order of doing things. First, you want to take the derivative, which tells you a new function, which generates the slope of a tangent line, etc., and then plug in the 27. So on this one, we would use that power rule. So 2/3 x to the minus 1/3. Plug in that 27, and then just use some algebra there. We should get 2/9. This video is kind of short, but it should give you plenty of info to answer those questions on Schoology.